Hello, everyone. Thank you for joining us for today's webinar. My name is Neil Foley, and I'm the Applications Engineer at RISE. Today, I'll be talking about integrating metal inserts and other hardware into assemblies of 3D printed parts, and I'll be discussing some best practices and useful strategies involved. I'll start by introducing metal inserts and how they can be helpful to you. So metal inserts in our case are simply metal hardware components that can be semi-permanently embedded into a 3D printed thermoplastic part. By combining metal components into assemblies with 3D printed plastic parts, you can leverage the high flexibility and low cost per part of additive manufacturing, but harness the strength and precision of metal hardware where it counts. Some of the benefits of incorporating metal inserts into your assemblies include simplifying your printed part designs and making stronger, smoother, or more precise features. Metal inserts can help to simplify the design of your parts because they've already been designed or optimized to provide quality functionality. For example, a threaded insert has already been carefully designed and tested to interface well with standard screws, whereas printing threads directly on a part can often require multiple iterations of testing to get the dimensions just right. Using the threaded insert allows you to skip that testing and doesn't require the use of thread features in your models. Metal hinges can also typically be implemented with less design and testing work than 3D printed hinges. Metal components will generally be very strong and precise, which, if used well, can improve the durability and accuracy of your designs. There are also some possible downsides to consider when deciding whether to use metal inserts for certain application. First, many metal inserts require additional post-processing time to install them, which can stack up if you plan to use many of them. They may also add a lot of extra pieces to an otherwise simple assembly. Considering these factors in advance can help you to determine which applications warrant the use of metal inserts. Next, I'll discuss some of the different kinds of metal inserts and how they can be useful. A threaded insert is a small metal tube or ring with screw threads, on its inner surface. They can be inserted into a part to allow it to interface with screws. Self-tapping screws are another option for fastening components together. It's best not to install and uninstall these repeatedly in plastic parts, as the threads they form can be worn down. Drill guide bushings are another common metal insert. These are similar to threaded inserts in general shape, but their inner surfaces are smooth, and they are sized to fit a specific drill bit. Drill bushings are a useful addition to drill jigs for ensuring that each hole that's drilled will be properly aligned. Inserting hinge assemblies can provide the strength and precision of metal hinges to 3D printed parts, even at very small scales. Another option is to insert hinge pins or axles, which can simplify and strengthen joint designs. Alignment pins are another application where a metal pin is inserted into a printed part, and this ensures proper alignment when that part interfaces with another component. Metal alignment pins are typically smoother and more precise than those printed with thermoplastics. Finally, fortification plates can be used to strengthen the part itself. If placed and inserted properly, metal plates can add a lot of strength to parts, without incurring the costs of manufacturing the part entirely from metal. A final application is to insert electrical connectors into parts and interface electrically with the protruding portion. So Rise printers and our proprietary material, Risium, have a few characteristics that make them particularly effective for use with metal inserts. Risium is a fairly rigid plastic, which makes it durable enough to benefit from the extra strength and precision of metal inserts, where softer plastics could warp or fail at lower stresses. Risium is also very unusual among thermoplastics in that it can be extruded at a much lower temperature than its decomposition temperature, which results in the fact that it does not emit any volatile organic compounds as it's printed. This also means that metal inserts can be added to Risium parts without any unhealthy emissions. Finally, because of our patented process of augmented polymer deposition, we are able to jet a functional release ink into the interface between the support structures and model structure, making it very quick and easy to remove supports from Risium parts. This allows parts to be post-processed in a few minutes or even a few seconds, making a lot of room for other kinds of post-processing, including adding metal inserts and other hardware. Now I'll discuss some things to consider when deciding what kind of hardware to insert and what processes to use for applying them. There are a few strategies available for inserting metal components, including using a soldering iron or a hand press. There are a few applications where a hand press will work well, but for most applications, a soldering iron is preferable. Using a hand press with a rigid thermoplastic will require carefully toleranced holes, whereas using a soldering iron will soften the material enough to accommodate imperfections. If you choose to use a soldering iron, you'll have to determine the proper temperature for the thermoplastic used in the part. For Risium parts, we maintain zero VOC emissions up to 400 degrees Celsius, so we typically apply metal inserts at 350 degrees Celsius. This is hot enough to melt the thermoplastic around the metal insert, and if the holes are adequately sized, the weight of the soldering iron is enough to press the component into place. So it's best to just guide the iron as its weight presses down rather than applying force, which could cause the component to sink too deep or squeeze material up out of the hole. Many metal inserts that were designed for this purpose will have their own soldering iron attachment optimized for their application. This specialized component is often not necessary, and more generalized attachments work for many kinds of inserts, but for applications that require special precision or control, it's best to use the recommended attachment. Regarding the kinds of metal inserts you choose to use, those with rough textures on the outer walls will hold the most securely. Smooth-walled inserts are acceptable in some cases, but it's not recommended that you use them for load-bearing or high-stress applications because the smooth walls can more easily slip outward from the inserted hole. So now that you've selected your hardware, there are a few things to consider when designing the holes into which your metal parts will be inserted. The first and most important consideration is the size of the openings. So to fully adhere the insert into the thermoplastic part, there shouldn't be any gaps between them. So it's best to make the cavities a bit narrower than the parts being inserted. Approximately 0.5 millimeter typically works well. For hardware with rough surface features for adhesion, it's best to treat the width or diameter as the average between the maximum and minimum measurable diameters. This will ensure that the melted material will fill in the gaps in the rough surface and fully adhere to it. It's also a good practice to slightly taper the walls of the cavity. This provides a bit more wiggle room for tolerancing and helps to prevent inserts from being placed crookedly. Another good practice is to include a hard stop at the desired depth of the cavity. This ensures that every insert will only sink to the proper depth, and this also helps prevent crooked placement by providing a flat base for the insert to land on. Finally, it's good to give the cavity an extra 1/4 or 1/2 millimeter of depth so that the exposed surface of the insert doesn't protrude from the surrounding surface of the plastic part. This is, of course, not necessary for parts that are intended to protrude in this way, like alignment pins or electrical connectors. So now let's look at one interesting use case of this application. This is a visual prototype for a pair of glasses frames printed in full color on the X-Rise machine. And by inserting small metal hinges, we were able to attach moving arms, making the frames functional and wearable. The metal hinges are also stronger, more precise, and simpler to design around than a similar joint feature printed directly into the plastic components. So now, just to quickly review some of the points that I covered today. Using metal inserts allows you to add strength, precision, and some different types of functionality to your parts that you may not have been able to get as effectively by printing those features just in thermoplastic. Also, the properties of Risium make it distinctively clean and safe for hot inserts. In particular, the fact that Risium parts emit 0 VOCs as they are melted for inserting or extruding. Also, we discussed how when you are planning to use metal inserts, you'll want to consider how well the hardware you use will interface with your plastic parts. And finally, you'll want to, after choosing your hardware, carefully design the insert cavities for best tolerance and alignment using a few of the strategies that we discussed. So that's all I have for this webinar. Thank you all for attending today. If anyone has any questions, you can type them into the chat box at the bottom of the GoToMeeting window, and I'll be staying online for a few minutes to answer them. And as always, you can reach me for further information at applications@rise3d.com. So I'll just give it a few minutes in case anyone has some questions. And other than that, thank you again for attending.